Hey everyone, it's Mr. Canfield, or so I think. Okay, so we did up to number 8. We have 5 more to do. All right, e to the x sine x. Integration by parts. Okay. So, with integration by parts, this is one possible thing that happens. So here we go. If I'm trying to pick u and dv, well, if I said u is e to the x, then du would be e to the x dx. If I said dv was sine of x dx, well then that would make v cosine of x. Nope. Be negative cosine, right? So let's see what happens here. So I can plug it into my form. Nope, v du. Okay, so if I do that, uv, well that's going to be negative e to the x cosine x. And then since it's a negative cosine and it's a minus, I know it's going to be plus cosine x e to the x dx. And we're right back where we started, more or less, because I've got like e to the x, and I should write this e to the x cosine x. Let's look at it that way. So I started with e to the x sine x. Now I have e to the x cosine x dx in there. And it's like, well, what's the... So this is the way that I'm going to continue the problem. But just for a moment, let's say that we thought, well, this is probably wrong then. Let me try going in an alternative method. Let me try instead... Let me try making u cosine x, so then du is negative sine x. Wait, shoot. Hold on. Let me try number 9. Let me say e to the x sine x dx. Okay, let's make u equal to sine x, so then du would be cosine x dx. And then I could make dv equal to e to the x, then e to the x dx, so then v would be e to the x, right? So if I do that, well then I get uv, right, e to the x sine x, then I get minus the integral of v du, so e to the x cosine x dx. Similar problem. Neither of these are turning out nice so far. It must be impossible. And that's where I'm going to say, no, it's not impossible. There's something that actually happens here. So check it out. Sorry, I'm currently monitoring some of my students through Securely, so I'm getting distracted a little bit. All right, so if we try this one, e to the x cosine x dx. Oh wait, I said I was going to continue this. Which one did I say? Yeah. So you should be with me on this one. So, I'm going to say u is e to the x again. That makes du e to the x dx. Then I see I can say dv is equal to cosine x dx, so then that makes v equal to negative sine x. Nope, it makes it regular sine x. Last time I made a mistake, it was on purpose. This was an accidental mistake. So let's see what happens if I write this one now. So I can rewrite this as uv, so e to the x sine x minus v du. So sine x, nope, e to the x sine x dx. Okay. All right, perfect. So check this out. This is like that thing I just wrote there. So what I could say is I can say the integral of e to the x sine x dx is equal to negative e to the x cosine x, and then I can, that answer I just got there, write that, plus e to the x sine x minus the integral of e to the x sine x dx. We can slap a plus c on the end. And I could keep going, but pause for a minute. Whoops. Look at this. What is that? It's the original problem. So it says, thing I want is equal to stuff plus stuff minus thing I want plus c. Another way, if you're not seeing how wonderful this is, well, check this out. I can add this integral to both sides. Now I have two integrals of e to the x sine x dx is equal to negative e to the x cosine x plus e to the x sine x plus c. If I divide both sides by 2, we have now found the original integral that we wanted is equal to this stuff. And notice how there's no more integrals left over. So if we kind of review what just happened here, we had two looping derivatives, and you could have picked either one. It works either way. But keep picking the same one. So like if I pick e to the x for u, don't switch over next time and make cosine u. I don't think it matters. I just am afraid I don't think I've tried it. I'm not gonna try it now. I don't want to make this video super long. It's definitely like valid or allowable, but I don't, if I remember correctly, it like makes it take longer or something. But anyway, you do integration by parts, and then you wind up having to do integration by parts on what you get. And sometimes you have to do integration by parts 3 or 4 times, but eventually you'll get to a point where on the right-hand side, somewhere in this super long string of things, you'll see the original question. And so then you can move that original question to the other side, and it's the only integral over here. The thing that makes this so good is this is the only integral. And I don't know what this is, but when I move it over here, now I've just got a bunch of stuff with no integrals left, and so I'm left with an answer. So, it's a pretty spicy trick. We'll do another one, number 10. The integral of sine squared of x. All right. So, gut reaction for this one, I'm like, well, it's something squared. Could I do u substitution, just regular u substitution? But the issue with that is I don't see the derivative of sine present anywhere. So what if we were to try thinking about this as sine times sine? The reason why I thought to do that was, well, I mean, I'm doing integration by parts. I'm supposed to have two things multiplied together. sine squared just means sine times sine. Maybe it's a trolley question where like that's all I gotta do. So let me try it. Let's see, for you, I'll pick, I'll pick one of them for you, take its derivative, and then I'll pick the other one for dv. So this time it's gonna be negative cosine. All right, so let's see what happens. So basically, I'm going to go and I'm going to see if I can eventually end up with a sine squared. That's kind of my thinking. So uv, negative sine x cosine x, and it's a negative, v is a negative, so when we do subtraction, a negative, it'll be plus. Hey, all right, I am actually done already. I don't need to do integration by parts again. You totally could though. Like if you don't see what I saw, what I see here is this. I can use a trigonometric identity. Cosine squared is equal to 1 minus sine squared. Just a reminder, I get that from knowing cosine squared plus sine squared equals 1, and then solving this for cosine squared. So this is another true identity. So I could replace this with this. And so I'm able to write this as negative sine x cosine x plus the integral of 1 dx minus the integral of sine squared dx. Right, just they both get their own separate integral because it's a plus or minus. And so that's the answer I want. Here's the original question. So now I can add this to both sides and get 2 sine squared x dx is equal to negative sine x cosine x. Oh, integral of 1 is x. And then we'll have a plus c, and then it looks like we need to divide both sides by 2. And there we go. So, pretty cool, pretty cool. The if you didn't take that route, you know, you kind of redo this all over again. Fine, no big deal. And I think in the next step, you'll still get a sine squared, and you'll be able to do the same kind of thing. All right, let's see what's next. X squared cosine of 3x. All right. Okay, so this is nothing new, but there is a way to do something called the tabular method. It's a visual organizer, saves you some space, saves you some time as well. And I forget it. I know I talked about it in the last video, like we're gonna do a tabular method. It's worthwhile to know, it saves you a good amount of time, especially if this was like x to the 5th. So I know that I start with u, and I just take derivatives till I get to 0. And then I start with dv, and I take integrals until I get to the end. So my first integral here is going to be what, sine of 3x? Oh, but because of that 3, it's going to be 1/3 sine 3x. And then my next one's going to be 1/9 cosine 3x. Oh, but it's cosine, so it's negative. And then my next one is going to be negative 1/27 sine 3x. And so here's how the tabular method, I know that we alternate, and I know we go diagonally. And if I remember correctly, it goes like this, and like this. And so my answer to this is going to be x squared, or 1/3 x squared sine 3x plus 2/9 x cosine 3x minus 2/27 sine 3x. And you might think I made a sign mistake. The piece I did not mention is these alternate signs. So I am gonna real quick double check. And if I made a mistake, I'm gonna go back and refilm this part of the video. Which you know I hate doing. So I got squared sine 3x. Okay, yep. So that's the tabular method. When you've got these infinite loops, that's a great way to do it. So cool, let's do another one. X cubed e to the negative 2x. So again, it's a matter of, well, I'm going to be picking x cubed for u and e to the negative 2x for dv. So I'll take my derivatives until I run out. So I'll get 3x squared 6x 6 0. And then I will just keep on taking integrals until I get to the end. So e to the negative 2x, 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 right? E is its own, e to the x is its own antiderivative, and it's its own derivative, but it's e to the negative 2x. So if I were to take the antiderivative of that, that would mean that a negative 1/2 would pop out front, right? Because if we take a derivative, a negative 2 pops out front. So we need to account for that negative 1/2. And then we'll get another negative 1/2, which this time is going to be positive 1/4. And then another negative 1/2, which is negative 1/8. And then another negative 1/2, which is positive 1/16. And then all I have to do is bop, 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 plus minus, plus minus. So negative 1/2 x cubed e to the negative 2x minus 3/4 x squared e to the negative 2x plus 6/8 is also 3/4, right? So 3/4. Oh, no, I'm not. That's not plus. Also minus x e to the negative 2x. And then minus, so 6/16, both divisible by 2. What is that? 3/8. E to the negative 2x plus c. So we would have had to do integration by parts, like what, 4 times to get this? And the tabular method lets us do it repeatedly, really quickly. Pretty sure tabular method works on non-looping ones as well. let's test that theory really quick. Let me go back to one. Let me see. Let me try it with like number 1. Wasn't number 1 like x sine x or something like that? Or x e to the x. Oh, no, 1 was x cosine x. So if my u is x, 1, 0, take derivatives till we run out. Du is cosine x, then negative, nope, regular sine x, take an antiderivative, negative cosine x. So I get x sine x minus cosine x plus c. Nope, plus, minus. Double negatives turn it to plus. All right, let's see if, what did I do wrong? I think I did something wrong. I feel like I made an oopsie. That's what I get for trying something. Just, where's my notes? Let's see. Oh, no, that's right. Oh, silly me, yeah, because that turns into a negative when you take its derivative. Yeah, okay. So, if you want to do tabular method all the time, I think the place that it's not going to work is those weird self-referential ones. But it's just a shortcut of the work that we've already been doing. So let's look at the last one now. The one that says we have to get a little bit clever. That was my lunch bell. So I'm going to go do that lunch thing, and then come back, and I'm going to try this one. It tells me I have to be clever. I'm going to try it live. I'm going to try it fresh, and then if I get stuck, I'm going to go and get some help on it, and then come back.